Hello everyone. Today we are going to see how to create a PCB on Proteus. Okay, so when you open Proteus, something like this will open. What you have to do is click on New Project. Here you have to give your project a name. So we'll give our project a name. Since we are building a power supply of 5 volt, we'll give it the same name. Yeah. Don't change this format. This is by default Proteus format. Click on Next, Next, Next. If you are going to use a microcontroller in your project, you have to create firmware project here, but since we are not going to use any kind of microcontroller here, so we don't need this. So let this be on no firmware project and click on Next. Finish. Something like this will open. Here you have to select what all devices you will be using and make the circuit. So for a power supply, first we'll need a power supply, AC power supply 230 volts, 50 hertz. Click on sine wave AC voltage source. Okay. Next, what we'll need is a transformer. Select the trans 2P2S device, simple transformer. Okay. Double click on it. See, this list goes on adding. Next, you require a bridge rectifier. So click on bridge, generic bridge rectifier. Bridge has been added to the list. Next, also we need electrolytic capacitor. So electrolytic capacitor, generic electrolytic capacitor. Next, we require a voltage regulator. Since we are making a 5 volt regulator of 7805, fixed voltage regulator will be required. 7805, yes. Then we'll require a resistor. Resistor. Next, we'll use an LED to indicate whether the 5 volt output is coming or not. Red LED. Yes. Okay. Also, we'll require a DC voltmeter. Click on DC voltmeter and place it here for the time being. Go back to components with this yellow component board. Okay. First, we need the AC sine source. We'll click here. Double click on it and you can change its properties. So amplitude, we need it to be 230 volts and frequency, we need it to be 50 hertz. Okay. Next, we'll need the transformer. Click on it, click here, place it, join the primaries to the source. Double click on the transformer. Here primary inductance and secondary inductance are there. Let the primary inductance be 1 Henry, and for 5 volt we require the secondary inductance to be 5.4 millihenry. Okay. Next, the capacitor, next the bridge, and place it here. Join the two terminals of the bridge to the transformer, and next we'll require capacitor. I'll put the capacitor here and I'll rotate this capacitor. Connect the terminals of the capacitor. And so this will go here. Next is the 7805. I'll move this to side. 7805, place it. somewhere here, place it anywhere and join these. Next will require the resistor, place it here, rotate it, make it a little systematic so that it's pleasing to the eye. Also the LED, place it here, connect these, connect these, connect this terminal. Also we have to place terminal and ground this, oh sorry, ground this. Also will attach the voltmeter across the load. Changing the capacitor value, double click on the capacitor, and for this we'll require a 2200 microfarad capacitor, so 2200 microfarad. Also resistance needs to be 330 ohms, so we'll change that to 330. Okay, so we have set 230 volt 50 hertz here, we have set the primary and secondary inductance here, we have set the capacitor value, we have set the resistance value, and let's check if the output is coming. Play. Yes, so as you can see the LED is glowing, as well as the voltmeter is showing plus 5.01 volts, that's almost 5 volts. So the circuit is working. Okay, once you have created the circuit, now we have to design the PCB layout. For that, click here this PCB layout button, click on it, and a new window will open. See, PCB layout. Here we'll have to place the components one by one. As you can see, there are 3 crosses here. These indicate that there is no package for the following device. This transformer has no package, this LED has no package, and sine source voltage has no package. So we'll go back to our circuit. As we are going to directly we'll stop the simulation first. As we are going to directly connect the sine to the primary, so we'll not be requiring this, we'll delete it. Also, what you need basically in a transformer is 2 points so that we can connect them to the bridge. So instead of this transformer, we'll use a connector T block. We'll use a T block, so delete that. Also, instead of the LED, we'll use a simple diode. So go again to component mode, and we'll select a T block connector H2, that is 2-point T block. Click on OK. We'll take it here, I'll rotate it 180 degrees, click on this, also here, and instead of an LED we'll use a simple diode, generic diode. Okay, yes, so we'll place this diode here. So the output will not come, but we are doing this so that the PCB layout can be done properly. Okay, so as you can see, there are no crosses. Now what we need to do is create the PCB layout. We'll do it one by one. So the first part was connector, that is T block. We'll place it here, rotate it left. Next was the bridge, place it here, rotate it. As you can see, the wires are already connected as per the circuit, so you don't need to connect them again. Next is the capacitor. We'll place it somewhere here. Next is the 7805 voltage regulator. We'll place it somewhere here. Also we can rotate the device. Yes, Oh no, maybe the first one was more pleasing. Next is the resistor. Place the resistor. Okay, and the next one is the diode. We'll rotate this by 180 degrees. We'll rotate this here. Okay, so basic PCB layout is done. What you need to do is do tracking, wire tracking. Also you need to place them as close as possible, so that less space is occupied while the PCB is created. It can be a little irritating, but be patient. Yes, now what you need to do is tracking. Okay, go to this track mode and just click on this one, so it will show you where the track needs to be connected. Directly click here. Next is this second, directly click here. Next this. Also you remember that if you have to turn, you can't take a 90-degree turn. Okay, this path cannot be selected. We'll delete this path. We'll go something like this. Just a second. Delete this. Click here, click here, click here, click here. And next is this. Okay, you cannot go straight below. We'll see what can be done about that. For this we can do this to this, here, this to this to this, and one wire is remaining. Okay, we'll have to modify this. I'll come back after modifying this tracks. Okay, so after modifying the tracks a little bit, something like this I have prepared. You can change the width of the tracks by right clicking, change trace style, and according to the width you can select this number. We'll select 25. Change trace style T25, trace style T25. Okay, I'll see about that. Just a second. Trace style T25, trace style T25, 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 T25. Okay, there has been error that this is too huge. Let's change this track a little bit, and just like this is more accurate, I think. Yeah, so something like this has been prepared. If you want to see a 3D simulation of this, click here next to this PCB layout. There is a 3D visualizer button. Okay, the PCB board is not seeing. Just a second. Go back to PCB layout. Go to 2D graphics mode. Click here, board edge, and draw a rectangle. Now when you go to 3D visualizer, as you can see, you can totally visualize how the PCB will look, and if you go to the bottom you can see how the lines are going. Yes, so it's quite a useful tool. Now since we have created this PCB layout, now we have to just export it. For that we will click output, export graphics, export Adobe file. Now you will have to use invert colors and mirror image as we are going to uh, trace it. Next is keep everything unticked in just leaving bottom copper ticked. So bottom copper is ticked and everything else is unticked. Select where you have to save this and click on OK. Let's see if we are getting an output. Yes, so as you can see, this is my final PCB layout. Thanks for watching.